One of the classic things we have to do in a database is to find information that isn't there. And so we need a particular kind of a join called a left join that looks for missing information. The classic metaphor for this is just subtraction. So let's step through how you do a left join.
All right, a new kind of query today that's going to help us ramp up our SQL skills quite a lot, called a left join. The diagram doesn't depict a left join, but I found this cartoon on the internet, Venn diagram humor, and I thought it was really great, so I just thought I'd put it on here. It has nothing to do with a left join, though. Okay. Now, the reason Venn diagram humor is appropriate is because underneath every MySQL query is a Venn diagram. MySQL thinks of every table as if it is a set. And so when we do a query, it starts to overlap circles, just like we did in Venn diagrams back in school when you were in school. It figures out what the answer is by constructing the Venn diagram properly. Now, in MySQL terminology, every time we do this, construct a Venn diagram, or we lay circles on top of one another, it's called a join. And so a multi-table query is more precisely called a join. And so we will use that terminology today. And most of the time when we look for something, we're actually looking for the middle part. We're looking for the overlap between the various circles. We've seen this a lot. Here's the basic template of the SQL down here at the bottom, right? We're just selecting some columns, whatever, from a left table and a right table where there's some, column key on the left, and that equals some column key on the right. And so technical terms here, blah and bleep. But this is technically called an inner join because what we're looking for is the overlap on the inside of those circles. In set theory, we would call this maybe an intersection. Now, that's not the only kind of join we have. There are a lot. So I've borrowed this one from C.L. Moffat, and I'll probably get, a cease and desist letter, but that's okay. It's a good diagram. The one that we've been working on is obviously the one right here in the middle, right? There's a set on the left A and a set on the right B, and we're looking for the football shape in the middle, and that is technically called an inner join. Every other diagram here is an outer join of some kind. And it's an outer join because you can see the red is the stuff we're keeping. There's always something outside that middle football shape. And because we're retaining something from the sets outside that middle football shape, these are technically all outer joins. Now, if you look at the two on the left, you'll notice that we're keeping more stuff from the A circle rather than the B. And because the A is on the left, you'll notice that both of those are left joins in some sense. And look at the right. We're keeping more red stuff from the B table. The B table is on the right. So technically those are called right joins. And if you look at the two at the bottom, we're keeping a lot of stuff, right? And so those are full outer joins. Now, we won't be doing any of those in this, actually probably in this series. I've had to do a few full outer joins in my whole long database career, but not very often, but just know they exist. All right. So as I mentioned, every query that we've done so far in this class has been an inner join of some kind. We're always looking for the intersection of those sets. Here it's diagrammed with two tables, but we could do it with more. So for example, the last multi-table query we did was this one. We looked at the citing table and we just tried to reconcile the foreign keys in the citing table of Bird Club. So instead of listing a person ID, we reached out to the person table to grab their first and last name. Rather than listing the bird ID, we reached out to the bird table to pull back the common name of the bird. So I know that this query is probably, you probably remember it by heart, but let's just review it quickly. So we just selected first and last and bird, common. from those three important tables, from the person, comma, sighting, comma, bird. And we needed those three tables because that's how we had to jump, right? Use the bridge to jump the islands in the stream. And we did that with primary and foreign keys. So the where clause became where we're going from a primary key in person to a foreign key in sighting, and also from a foreign key in sighting to a primary key in bird. And that's what gets us back to this table, right? Now, if I had to draw that as a picture, as an inner join, I'd probably draw it like this. We just have three overlapping circles for our three tables, three sets. And what we're doing is looking for the set or the intersection of all three of those circles. And we pull back some columns, but this is really the area we're looking for. Now, as you get to more tables like 4 and 5 and 6, obviously this is going to be really hard to draw. So it's going to be easier to imagine rather than draw these things. To go forward with our newfangled queries, we have to confront now the fact that we have been working in a kind of a dialect or a slang version of SQL. Well, that's fine. The slang version is taking over, but it's time now that we start to have to write what I'm going to maybe call Queen's English SQL. We have to write it properly. So here's our left-right inner join query, and what we've been writing is what's on the left. So we're selecting a bunch of columns from the table on the left, comma, the table on the right, where some sorts of keys are equal. I just call them both IDs, but whatever. Now, in Queen's English SQL, in more standardized SQL, how we would write that is what's on the right. We would select a bunch of columns from the left table, inner join the right table on some sort of a primary key, foreign key relationship. Now, what's interesting about this is that MySQL decided that the comma was going to be synonymous with inner join. That just makes things a little easier for us. And it also decided that we could use the where clause to tell MySQL how to align the 2 or 3 or 4 tables. So in kind of Queen's English SQL, we have to use the on keyword, but in MySQL, we can do that with a where keyword. Now that's important because as we move into left join, we're going to have to be writing more proper Queen's English SQL. And in fact, we can go back and write that last query as more proper Queen's SQL. So notice now I'm selecting all of those columns still, but now I am selecting from the person table, inner join sighting, inner join bird. Again, when we wrote that the first time, we used commas, but the comma is synonymous with inner join, so I can swap those out. And then I have to use the on keyword to tell MySQL how to map between tables or how to map those keys. So going from primary to foreign key and foreign key to primary key is in a giant two-line on clause. But this is exactly the same query as we wrote before. Just before, we were writing it with a bit of a MySQL accent, and now we're writing it in more proper, standardized SQL. Here's the general template then that we're using. And I've added a where clause here. So let's just imagine in your head doing this same query again, but we have a where clause at the end, like maybe where the date of the bird sighting is in the month of June or something like that, right? So we'll add some sort of weird where clause at the end. But here's the general standardized version then, is the from clause is going to have this inner join, citing inner join, inner join. And that's because the from clause not only tells MySQL which tables to use, it actually tells MySQL which type of join we want to have. So comma means inner join, But if we want to use a left join, we can't use the comma. We have to tell MySQL which type of join we're using. So that could be an inner join, it could be a left join, it could be a right join, and it could even be a full outer join. All of those are possibilities now. But in order to affect the kind of join that MySQL wants to do, we have to be very explicit to tell it. Secondly, the on clause tells MySQL how to align the rows of the tables when they're getting joined. So think about this in circles, and sometimes I imagine this as a 3D thing. So you've got maybe pieces of paper, or maybe they're plastic toys. And so we have to rotate the tables properly, or move them up and down, or move them left and right, and then eventually they kind of snap into place like little, Lego toys, circles or something. Maybe you can think about it as like locks and keys, right? So you have to line up the one that has a lock, and you have to line it up with the key of the other one, and eventually they'll kind of snap into place. Now, when we were doing this before in kind of MySQL accent, I used the metaphor of island hopping, and that every foreign key relationship, primary foreign key relationship, was a bridge, and we're hopping from tables, which are islands. That still works, I think, but here, when we're using the on keyword, we're really telling MySQL, how do you align those tables? And then finally here, the where clause gets used in its most proper form, which is that where determines whether to include or exclude rows from the final answer. So MySQL is going to construct a whole bunch of rows, and then it will start at the top, and it will apply those criteria to every single row. It will keep some of them, and it will throw some others away. But that's what the where clause does. Now, when we're speaking MySQL accent language, the where clause does double duty. It both serves as the on clause and as the where clause together. But when we're writing more standardized SQL, you'll notice that those two roles or those two functions are different. On and where actually serve different purposes. But it's this kind of standardized SQL that we're going to have to start to write from here on up. All right, so just as a repeat, here are all of those joins again then. So everything that we've been doing are these inner joins. And now we're going to work on those two on the left, because those are our left joins. So we'll take this one. So what we're going to do with a left join is we're going to join these two tables, and we're going to look for rows that exist in A, but that do not exist in B, right? Or to say it a different way, we're going to look for rows in A. No, I'm saying the same way. We're going to look for rows in the left one that don't match rows in the right one. And this is a classic strategy when we want to look for missing information. So the left join is our first really big step in ramping up our SQL fluency. So let's just talk through a couple of examples here before we get to the syntax. So let's imagine that I want to, in Bird Club, that I want to find out all the birds that have not been seen by anyone. So what I do with my two tables is that I will take all of the birds. We already have that because that's in the bird table, right? So I'm going to, metaphorically speaking, I'm going to take all the birds in the bird table, and then I'm going to subtract all the birds we've seen in the sighting table, and what I have left over will be birds that we haven't seen yet. So when I start to subtract, what happens is that the sighting table takes a bite out of the bird table. That is to say that some rows from the bird table will not be represented anymore because they will be absorbed or taken over by sighting. You think of it a different way. Like we've laid bird table on top of sighting table. They're both pieces of ice. I'm using all these metaphors now. We'll just find one that works for you, right? They're both little pieces of ice, but the birds we've seen, that is to say the sighting table, is warmer than the other one, and so it melts away. Okay, that's not working for me, but hopefully that maybe works for you. All right. And then what we're left over then at the end, we don't care about the sighting table anymore. What we do care about is the birds that we haven't seen. And so this is going to be a subset of the bird table. And so all of the birds that have been seen will be subtracted from the bird table. Now, in theory, if we saw every bird, there just wouldn't be any left over, right? So this subset here would actually be the empty set. There just wouldn't be any. That's possible. And again, just as a repeat, this is the diagram that we're looking at. So what we're left with are those extra rows from the A table or the left table once we subtract all the rows from the B table or the right table. So let's just talk through the syntax here then just for a little bit. We have this table on the left. We have this table on the right. And so the table on the left really is a kind of master list of something. So the bird table is a master list of all the birds. The person table is a master list of everybody who's signed up for Bird Club. The table on the right are the incidents of something or events or occurrences that we want to subtract. So in our case, it's going to be the sighting table. So if we want to know which birds have not been seen, we'll put the bird table on the left, we'll put the sighting table on the right, and subtract. If we want to know all the people who have not seen a bird, we'll put the master list of people on the left, and we'll subtract everybody who saw a bird in the sighting table on the right. So here's how we start. We have to join those two tables. And again, we're writing this in more Queen's English SQL now because we have to tell MySQL how to join the tables. We'll see how this happens under the hood here in a little bit. So to start, we're just going to select a bunch of columns, fill in the blank, whatever we're going to select. But now we're going to select from the table on the left, left joined with the table on the right. And so that tells MySQL what kind of join we're going to do, what to produce. And then we have to tell MySQL how to align the tables. So when it lines them up, we have to have a kind of a shared key or a column that's in common or something like that. And so this is our on clause. So we're going to have a column on the left dot underscore something, blah, 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 blah. And the value in that column is going to be equal to a column on the right. So right dot underscore blah, blah, blah. Now, most of the time, usually, these are going to be a kind of a primary key, foreign key relationship. And that makes sense, right? Because this is what relational databases do. We've spent so much time designing databases, building databases to capture these relationships and to make sure that we're preserving the data integrity of the relationships between these parts. So it's not unusual that this is going to be a primary key, foreign key relationship, but it doesn't have to be always. All right. And then finally, we're going to select the elements that are on the left, but that do not occur on the right. And that means that the right-hand column is going to have a value of null. It's not going to exist. Now, where did the null come from? Well, it came from the left join. And we're going to see that in a couple of minutes. I'm going to show you under the hood what it looks like. We're going to step through the left join so that you can see what it is. But it makes sense, right? So let's imagine that person number 7 on the left never saw a bird. It kind of makes sense that if we ask for person number 7 in the right table, but person number 7 doesn't exist, the absence of a value is null, right? So we're looking for things that occur on the left, but that are null on the right. And again, we'll look under the hood here in a couple minutes to see that. And then, of course, what remains are just the things that are left over. So it's all of the elements in the master table once we have subtracted a different table. right, let's look at a different example here. This isn't even a database we've built, but let's imagine that I'm a teacher, somebody's a teacher, and they just want to find out which students have not yet taken the exam. Well, we left join to the rescue. So the master list is a master list of all the students. We'll put that on the left. And then we'll subtract the grade book. That is to say, all of the students who have taken the exam. And then obviously what you're left with are students who have not taken the exam. So that process of subtraction kind of, I imagine it this way, like the blue table on the right eats away some of the records from the yellow table on the left. And so what you're left with in the yellow table is that kind of moon-shaped structure, right, of students who have not taken the exam. Now, once you get used to working with this idea, you can start to recognize tons of questions in English that are actually left join queries. So just to take a couple of bird club ones here, right? Which bird club members have not seen a bird? Well, we can imagine that we're subtracting from all of the members as a master list the sightings by people, right? So the table on the left is going to be the person table, and the table on the right is going to be the sighting table. So it's going to be person minus sighting is members who haven't seen a bird. And similarly, stating in Bird Club, which birds have not been seen by anyone? Same strategy. Birds now is the master list from which we will subtract the sighting table. So it's going to be a similar sort of situation. Which students have not taken the exam? Well, we just did that one, right? So we have a master list of students. We have the grade book. So it's going to be a student list on the left, and on the right is going to be all the exam scores. Here's one we haven't built. We don't even need to. Which painters have not sold a painting yet at my art gallery? Well, we don't even have to build that structure. We know that it's somewhere on the left, we're going to have a list of all the painters. Maybe there are painters that we have relationships with at the art gallery. Who knows? And on the right-hand side is going to be gallery sales. Now that table might have a ton of stuff on it, right? A gallery sales table probably has, a primary key. Maybe that's a receipt record or a receipt number, perhaps. It's going to have a foreign key for the painter. It's going to have a foreign key for the title of the painting. It's going to have a foreign key for the buyer. It's going to have a date. It's going to have a price. It's going to have a ton of stuff on there. It doesn't matter. The painter table here could be a full entity table. The gallery sales table could be a full entity table. But it's those two that we need in order to figure out who hasn't sold a painting. Because we take the master list of painters and we subtract the gallery sales. So what's important about this is way back when we started designing databases, we design better databases when we can envision how we're going to use them. And if I know that I'm going to do a left join query, then I know that I'm going to have some tables that are kind of quote-unquote master lists of stuff. And I'm going to have other tables that record things like bird sightings or exam scores or sales receipts at the gallery. And if I subtract from the master list that other table, I can see who hasn't done something yet, right? Now here's one that we did, right? If you're working along, this was one of the examples that we used when we were designing the database table. And so which bike tour spy locations have not reported a bike tour? Well, we kind of know how that's going to work now too, right? That we're going to have a master list of every location where we've sent a spy, and that might have some extra info like the date they arrived, the date they left, whether they had a good time, whether I have to reimburse them for fees, who knows what. Could have a ton of information on that. But on the right-hand table then is going to be the reported sightings of our competitor bike tour company. Like where have they come through and when? I subtract from all SPY locations the locations where they did show up, and I have left over locations where they didn't show up. Right? Which club members haven't paid their dues yet? Well, now you see the pattern, right? Working through enough of these, you start to see the pattern. We're going to have a master list of members, everybody who's in the club, and then we're going to have a table for dues received. Who paid their dues? How much? What's the date? Did they get a receipt? Did they pay in cash or Bitcoin? Whatever. So the dues could have a lot of stuff. So we take the membership list, we subtract everybody who's paid their dues, and the people left over have not paid yet, right? Customers who hasn't received their delivery. Well, we're going to have a master list of all customer orders. And then maybe we give our delivery drivers an app, right? It's on their phone. And so they call up the order and then they tap on it when they actually have delivered it. And so they get a timestamp in the database, et cetera, et cetera, et cetera. So we could build a really cool app system based on this. But if the boss wants to know today which customers have not received their deliveries, we look at all open orders. And well, they might even be open. That the customer orders may not even tell us whether it's open or closed, right? So we look at all of the customer orders, and then we subtract from them all of the ones that have a delivery driver report. And whatever doesn't have a delivery driver report is open, hasn't been delivered yet, right? That's good. All right. So now what I want to do is I want to show you a little bit more closely how the left join gets constructed under the hood. In particular, where do those null values come from? That's what I want to show you. So we're going to move over to the terminal window, and we're going to load up a smaller database than Bird Club. It's just a little bit easier to work with. It has fewer rows in it, and that's actually the books one that we've been constructing in the last couple of videos. So if you haven't played along with that, there is a dump file on eClass, so we'll download that and we'll load it up. And then I want to do some left joins on that query so that we can see how it works. Here in Terminal, I have already gotten into MySQL, but one of the things I have done is I have dropped the books database. So I'm going to source it again. Now, I'm going to show you one other little trick here. I want to see what the name of that file is. So I'm going to do a \!! And that's going to allow me to run a command on my shell. And so I'm going to do a directory listing and one line at a time. And so there's my file. It's called books.sql. Okay, great. I just needed to remember that. All right. So I'm going to source books.sql, and I don't need a semicolon there. And I've just imported all of that. So now I can say show tables. Here are my 3 tables. If I do select star from book, I'm not going to fall for the trick again. Big capital G. There are my 3 books. So head first PHP, book 1, 2, 3. Okay. I'm going to do, let me try in all caps here. Select star from person. And you'll notice I've got my 6 authors. Some of these are authors, some of those are editors. If you played along with the other videos when we're working on this table, this database, you can see it. And then finally, select star from role. And here are all my foreign keys, right? Person 1 has a relationship to book 1 as an author, blah, 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 blah. Person 5 has a relationship to book 3 as an editor, etc., etc., etc. All right. So let's imagine I want to find out if there are any books who are not represented in the role table. So books where I forgot to put in an author or an editor. And then let's imagine that I also want to know if there are any people who are not listed in the role table. So do I have extra people here that I never needed to put in? We'll find that out. All right. Well, as you might have guessed, I've taken the liberty to copy and paste the left join query. So we're going to start with books first. So I'm going to select book.star. So remember, star means everything. So I'm going to select every column in the book table. And I'm going to do that from book on the left join role. Now I need to tell it how to align the tables. And the alignment here goes from the primary key in book, so book.id, to the foreign key in role, so role.book_id, right here. And I want to know every occurrence where the book ID over here happens to be null. And there aren't any. No, that's okay. That's actually what I would have expected to have happen, because every book has an author. There we go. Every book has an author or an editor. So what this tells me is that I don't have any people left over. Now that's okay. This is what I want to have happen because I want to show you when we add a new person what's going to happen. All right. So I'm going to do the same query, and I'm going to do this one at a time. So now I'm going to do, I'm just going to add these as we go. Person.star from person left join role on. I'm going to have to change that one. So now I'm not working with the book ID. I'm working to align the person ID primary key. Oops, sorry. Still to role. To the role foreign key, which is called person ID. Where person ID. Sorry, I have to think I had. There you go. Oh man, that was a long time. Okay, so there's the left join. So the left join doesn't show me anybody, right? So that's okay. That tells me that all the people are accounted for, right? Okay, now let's do that again. I want to add a new person, and then we will see that this person left join gives us a new person. So I'm going to insert into the person table, first and last, values. Let's do the famous 16th, 17th century playwright Kit Marlowe, who was probably a spy and was probably murdered. Exciting story. So we're going to insert into, so now if I do select star from person, now you can see that I've got Kit Marlowe down here as person number 7. But Kit Marlowe does not exist in the role table. So when I do my person left join again, I should get Kit Marlowe. So I'm just going to go up. We'll do this one line at a time so you can see it a little better. So I'm going to select person.star from person left join role. Now my on clause. On the person primary key aligning with the person foreign key in the role table, and I want to select those rows where the person ID is null. That's Kit Marlowe. So what that tells me is that Kit Marlowe does not have a row in the role table. So I've taken everybody in the person table, and I have subtracted all of the person IDs from the role table, and who's left over is poor Kit Marlowe, that guy. All right, let's go a step further. What I would like to do now is to repeat the last query, but I am going to remove the where clause, and I want you to see what is produced by the left join. Now when I do that, I'm not just going to want every column from the person table. I'm going to want every column from both tables. I want to see everything, so I'm going to do a select star. So let me just type that one. That one's easier to type. I'll just start a select star. I'm going to select star from person left join role on person ID primary key equals role person ID foreign key. Now I'm going to leave off the where clause. Remember what I said, this left join is going to produce a whole bunch of rows, and what happens when it hits the where clause, when MySQL does the where clause, is it starts at the top and it starts applying criteria, and it decides whether to keep the row or to exclude the row. So I'm going to omit the where clause so that we can see what MySQL produces from the left join, which is this. So you will notice that the first 3 columns come from the person table, and the last 4 columns come from the role table. Now this is not the intersection, is it, of those 2 tables. This is an outer join. So we get all of the columns. We get all the columns from the left table, and we get all of the columns from the right table. Now, they're all lined up. So Lynn Bailey is person 1 and book 1 author, etc., just like we saw before. But notice what happens on Kit's row. So now, Kit Marlowe does not have any rows in the role table. The absence of a value is null. So the only thing that MySQL can logically do is to put nulls in all of those values, in all of those columns. So Kit does not exist in the role table, and so therefore all of his values over there are null. So this is where the nulls come from, and this is what allows us in a left join where clause to look for nulls. All right, a little chalk talk about what we just did so that we can review and I can add some new information. So the first thing that we did in the book table was that we checked to see if there were any books that were not listed in the role table. And the way to do that is a left join, and the empty set shows us that everything is there. So if you want to think about that as a diagram, right, we've got the book table on the left, the role table on the right. When we subtract role from book, there's nothing left over, so that is an empty set. So that tells me that everything is being used. And then we did the same thing with the person table. We looked for all people and who are not in the role table. Same thing. When we have all the people in person, subtract all the people in role, there was nothing left over. It was empty. So that meant that all of our people were accounted for. And then what we did was we added Kit Marlowe. And now we did the left join again, but now we did have one person. So there's one person in the person table who is not in the role table, and that's Kit Marlowe. That's exactly what we would expect. And then we did this, and this one is what I think helps you to really understand what the left join does. So we repeated the query, but we left off the where clause, and the where clause again includes or excludes rows, and so we included all rows. And what we saw was that this row for Kit Marlowe had a bunch of nulls in it because he doesn't have an entry in the role table. And the absence of a value is null, and so MySQL dutifully tells us that all of those values are null. The reason that it looks the way that it does is because in the join, it actually aligns everybody in person with something in role. So the 3 columns on the left are from person, and the 4 columns on the right are from role. Now, how did it line those up? Well, that's what we have to look for in the on clause. So the on clause says match up the primary key in person to the foreign key in role. And so it is these 2 columns in the on clause that lines things up. Now, this is a small table, and we didn't add many people, so everything's 1, 2, 3, 4, 5, 6. So it's not intuitively easy to deduce, perhaps, right, that we're matching person.id to role.person_id. But that's what the on clause says. So this is how it lines up. Now, if we were missing some, that's okay. These are the 2 columns that MySQL is going to use to align the 2 tables. Now, if you want to try this is the reason I didn't use Bird Club, is because there are too many rows. So on your own, if you want, try this in Bird Club to see what you get. So do a select star from person left join citing and see what you get. I'm just going to give you a hint There are 31 rows there. Are there 31 people in Bird Club? Nope, there are not. So we get more rows than are in the person table, and we get more rows than are in the sighting table. And then the same thing, if you do the same thing with select star from bird, left join sighting, and omit the where clause, you will see 32 rows in that set, and you're going to see a whole bunch of nulls. Where did the nulls come from? The nulls came from the left join, right? Now, when you practice your left joins, put the where clause back on, and then you're doing the left join. So I'm not going to work through that because I'm just going to let you guys do that on your own. All right, that's my short interlude. All right, so here's the review of that. The left join lines up every row in person with every row in role. And it does that by matching those keys the way that we told MySQL to do in the on clause. Now, however, because Kip Marlowe does not have any rows in the role table, the only thing MySQL can do is put in null, because nothing exists. It's the absence of a value. And so that's the clue for doing the left join, and that's the clue about why we look for null on the right-hand side. All right. Now here's the other truth of that thing that I wanted to show you. It's common to write this in the way that I did, right? Select star represent on person ID equals role dot underscore person underscore ID, and then I look for that same thing to be null. But you'll notice everything is null on the right-hand side. The ID column is null. The person ID column is null. The book ID column is null. The role column is null. They're all null over there. So to be perfectly honest, the column that I choose for the where clause is pretty arbitrary. I could pick anything. So I would get the same result if I replaced the where clause with where the role table, the role column happens to be null. I would get exactly the same thing. It's because Kit Marlowe doesn't exist, and so therefore every column in the role table will be null. So I've got my choice there. Anyone is good. One last thing before we go. You may have wondered if it's possible to do this as a right join. Okay, maybe I'm the only one. I've read tons and tons and tons of database books, and no one ever does a right join. They just simply don't exist. Like, everybody does a left join, but no one ever does a right join. And so I went along for years thinking that right joins were just impossible. And one day I was maybe a little bored, and I thought, is it possible to do this as a right join? And the answer is, it sure is. It's exactly the same, but no one ever does it, and I can't tell you why. All right, so here's what we're going to do. Just hang with me for a minute. It'll be okay. So here's what we just did. Select, this is the Bird Club one. Select star from person, left join, sighting, etc. And that gives me the list of people who have seen no birds. Now, if I wanted to do this as a right join, it just makes sense, doesn't it, that I would flip these around like this. So can I do it? And the answer is, of course I can do it. It's remarkably the same. So what I'm doing is I'm selecting person.star from sighting on the left, right join person on the right, on the same key that I used before, where the where clause is the same one that I did before, and I get exactly the same answer. So is it possible to do this? Yeah, it certainly is. It's not even difficult. Once you really kind of intuitively grasp the geometry of it, I think that these are pretty easy to write, to be honest. So there's really nothing different there, and what we get is a moon-shaped person table that's left over, right? All the people who never saw a bird, and it's exactly the same. All right. And that's it for left joins. Now, one of the other advanced query things we're going to do is a subquery. And we are going to do some more left joins when we get to subqueries. So that's something for you to look forward to. I'll see you then.